representation of rational numbers in decimal system. We already learnt about representation of rational number into decimal system. We know that decimal representation of rational numbers is terminating or non-terminating recurring. Example: 2.15 is equal to 215 upon 100 is equal to 43 upon 20. 2.003 is equal to 2003 upon 1000. 1 upon 3 is equal to 0.3333 up to so on. 1 upon 7 is equal to 0.142857, 142857 up to so on. If expansion of rational number has terminating, then it is in the form of A.A1, A2 up to AK, where A is an integer and A1, A2, A3, so on up to AK are numbers after decimal point. In 322.47891, A is equal to 322, A1 is equal to 4, A2 is equal to 7, A3 is equal to 8, A4 is equal to 9, A5 is equal to 1. We can write it as follows. A.A1, A2, A3 up to AK is equal to A plus 0.A1, A2 up to AK is equal to A plus A1, A2 up to AK upon 10K is equal to A plus A1, A2, so on up to AK upon 2 raised to K into 5 raised to K. Now cancel common factors from A1, A2 up to AK and 2 raised to K, 5 raised to K. So we get reduced form as M upon N. Therefore, A.A1, A2 up to AK is equal to A plus M upon N. GCD of Mn is equal to 1 and N is equal to 2 raised to P, 5 raised to Q, where P and Q are not more than K. Theorem: if a rational number A has terminating decimal expansion, then we can represent it as A is equal to P upon Q, where GCD of PQ is equal to 1 and Q is equal to 2 raised to M, 5 raised to N, where M and N are some non-negative integers. Let us consider the converse situation. Suppose A is equal to P upon 2 raised to M, 5 raised to N. If M is less than N, then A is equal to P upon 2 raised to M into 5 raised to N minus M into 5 raised to M is equal to P upon 2 raised to M into 5 raised to N minus M into 5 raised to M into 2 raised to N minus M upon 2 raised to N minus M is equal to P into 2 raised to N minus M upon 10 raised to M into 10 raised to N minus M is equal to P into 2 raised to N minus M upon 10 raised to N. For example, 2003 upon 2 raised to 3, 5 raised to 4 is equal to 2003 into 2 upon 2 raised to 4, 5 raised to 4 is equal to 2003 into 2 upon 10 raised to 4 is equal to 4006 upon 10 raised to 4. Similarly, if M is greater than N, then A is equal to P 5 raised to M minus N upon 10 raised to M. For example, 2521 upon 2 raised to 5, 5 raised to 3 is equal to 2521 into 5 square upon 2 raised to 5, 5 raised to 5 is equal to 25 into 2521 upon 10 raised to 5. If m is equal to n, then a is equal to p upon 10 raised to m or p upon 10 raised to n. For example, 1467 upon 2 raised to 5, 5 raised to 5 is equal to 1467 upon 10 raised to 5. Theorem. If a rational number is in a form of a is equal to p upon 2 raised to m 5 raised to n, where m and n are non-negative integers, then decimal form of a has a terminating decimal expansion. A rational number a has terminating decimal expansion if and only if it is of the form p upon q, with q is equal to 2 raised to m 5 raised to n for non-negative integers m n. If decimal form of a is equal to p upon q is non-terminating recurring, if and only if q is not of the form 2 raised to m into 5 raised to n. mn belongs to n union 0, or in other words, GCD of PQ is equal to 1 and Q has at least one prime factor except 2 and 5. Example. State whether the following rational numbers will have a terminating decimal expansion or non-terminating recurring expansion. Write down the decimal expansion of those rational numbers which have terminating decimal expansion. 1. 23 upon 2 raised to 3 5 raised to 2. 2. 12 upon 35. 3. 337 upon 125. In first example, denominator is in the form of 2 raised to m into 5 raised to n. So, it is terminating rational number. Multiply and divide it with 5. We get 23 upon 2 raised to 3 5 raised to 2 into 5 upon 5 is equal to 115 upon 2 raised to 3 5 raised to 3 is equal to 115 upon 10 cube is equal to 0.115. In second example, GCD of 1235 is equal to 1 and 35 is equal to 5 into 7 has one factor 7. So we cannot represent denominator in the form of 2 raised to m 5 raised to n. Therefore, 12 upon 35 does not have a terminating decimal expansion. In third example, GCD of 337 125 is equal to 1. We can represent denominator in the form of 2 raised to m 5 raised to n. 125 is equal to 5 raised to 3 into 2 raised to 0. Therefore, 337 upon 125 is terminating rational number. To represent given rational number in decimal form, multiply and divide it by 2 raised to 3. Therefore, 337 upon 125 is equal to 337 upon 5 cube is equal to 337 upon 5 cube into 2 cube upon 2 cube is equal to 337 into 8 upon 10 cube is equal to 2696 upon 10 cube is equal to 2.696. So, decimal form of 337 upon 125 is 2.696.